Welcome to this particular experimental class. In this class we will show you one particular sensor which is called infrared sensor. It is also called IR sensor, and here we will be showing the actual application of IR sensor by looking at the distance that it can measure and which properties on which kind of surfaces it will not be useful. For example, if you take a black surface, whether you can use IR sensor or not. If in the experimental class you will see that when the student is moving his hand, the variation will be changing depending on the what is the distance between the source and the reflection boundary. And like I said, we will also show you if you change the kind of material, the reflection property would change, right. So, enjoy this lab class. I will see you in the next module. Bye.
Now we are going to discuss about a IR based distance sensor. So this is another sensor that we have got here. We will be discussing about this now. Okay. So you can see on the right hand side, I will be showing the working principle of it. Okay. So what happens is, you can see two LEDs over here, one coated with black and another one over here that is transparent white. Okay. So this is a together forms the transmitter and the receiver. So you can see the IR sensor working over here, that the white one is the transmitter and the black one is the IR receiver. So what happens is, you know that the light undergoes reflection, right. So when the transmitter sends the IR signal, if an object is there to reflect it, it will come back to the receiver. So based on the this reflection, the receiver will get this IR light back and it will sense it. That is what happens in this sensor. So you can see that the object is very critical here. If the object is not here, it is this light ray is going to go to infinity and no reflection will happen. But at the same time, if the object moves towards it, then the receiver will detect some reflection and will detect that the IR is bouncing back or an obstacle or object is close to it. And another main property of the object here should be that it has to be white, or it should be some reflecting surface. Okay. So a white surface will reflect the light that is coming to it. So a white object will reflect the light. At the same time, if we are keeping a black body or a perfect black object over here, then the light ray coming from here or the IR rays coming from here won't reflect back to the receiver. I will be demonstrating both of these examples. So this is about the working principle of the IR. Okay. So you can see a trimmer over here. This is to adjust the range at which we should detect. So this sensor module here, this is a working principle, but this is the sensor module or the commercial sensor we have got to show you the working demo. Okay. It has a differential comparator on board. So LM393. So what happens is, when the receiver detects the reflected light, it will measure its intensity, and based on this intensity, a comparing is done with the threshold that we have set using the trimmer. Okay. So based on this value, a digital output will be given out as either high or low. So this is it. So this sensor module can either work in a high level mode or a low level mode, or active mode or passive mode. So in the active mode, what happens is that when there is no reflection, you will be getting a high output, and in passive mode, when you get reflection only, you will be receiving a high output. Okay. This can be used for different applications. So it can be used for some intruder detection, that is like if a person walks into your house without your knowledge, if that person cuts the transmitted light over here, then it will make a noise, or we can trigger a buzzer or something. Okay. Similarly, you must have seen the obstacle avoider robots and other things. It will have a sensor like this on board. So if it moves towards a wall or another obstacle, the light will be reflected, and based on which the robot will be understanding that there is an obstacle ahead and it can change its course. Okay. So there is a maximum detection angle, that is 35 degree, beyond which it cannot detect. Okay. That is it. So I will be showing you the working of it. You can see here the sensor I have talked about. Okay, so this is it. This is the trimmer that I showed you to adjust the threshold, and this is the receiver LED, and this is the transmitter, and here you have the LM393 differential comparator. Okay, and you can see a 3-pin out, that is, one is output digital value and one is ground and one is VCC. So this is the LED we have to show that it's working. Okay, so this is the sensor, and I have connected to Arduino Duo and a buzzer also. I will be explaining the pins and other things on the code. So in the Arduino code you can see that I have defined the sensor pin as 3. That means the digital output of the IR sensor have been connected to the pin number 3, and the buzzer is connected to pin number 22. And in the setup I have defined the buzzer pin as output. That means the buzzer is going to give an output, that is the sound, beep sound, and the sensor pin is the input, and I have defined it because the sensor pin is connected to a digital input pin, that is pin number 3. Okay, in the void loop I have set the an integer sensor value is equal to digital read of sensor pin, because we are taking a digital value input from the sensor pin, that is pin number 3. And you might be thinking that why I have kept integer and what is the value that is going to be stored in the sensor value. So it's a digital read operation, that means it can only have 2 states, either high or low. So what value gets stored in sensor value is corresponding to high, the sensor value will store 1, and corresponding to sensor value low, it means the integer sensor value will be storing the value 0. Okay, so corresponding to low, the value stored here will be 0, and corresponding to the digital read of a high value, we will be storing here 1. And instead of integer you can use boolean operation also, bool. Okay, so I have used integer only here, and you can see that I have used the if function. So if sensor value equal to high, then digital write buzzer pin comma low, because I already told you that this sensor is actively low. That means that by default this sensor if it detects nothing, it will be high only. So if it's not detecting anything, we need not have need the buzzer to make any sound. So I did it like that. So it is by active, that means if it detects nothing, it will be giving a high output. So I have defined the buzzer pin as low, and otherwise, that means if the sensor value is low, then I am turning the buzzer pin high. Okay. So I have uploaded the code to the Arduino Duo, so you can see here. Okay, I am just showing my hand over here. You can see that a light is blinking, that means it's detecting something, and at the same time the buzzer is making the sound. Okay, so this is what. Now this is the distance at which it is sensing it. So I can just adjust the potentiometer or the trimmer. So when I reduce the value too low, it is making the sound because we have adjusted it to a very low value. If I increase the range, it's not detecting at all. It went too high. So you have to adjust it to a intermediate value for it to detect. See, I have reduced the value now. Okay, initially it was somewhere here. Okay, and one more example I have to show is, I told you the color of the object also is important. So I have a black phone over here. Okay, the surface is black now. If I show here, it's not detecting because the black surface is not reflecting. The green gloves I am using is still reflecting, and the white here surface here also is reflecting, but the mobile phone which is black is not reflecting. Okay, so this shows that the IR can only be used when it comes to a obstacle or an object that is white or have a reflecting surface. Okay, so this is about the IR sensor.